Let's go. It said go on the screen. We're gonna go.
Where are we going?
We're going, man. All right, go.
Where are we going?
We're gonna talk slopes and rates of change today. Oh, good stuff. Good stuff. Slopes and rates of change. Love it. Okay. All right. So, let's do it, man. Let's get into it. So, if I said describe for me, so now when I say describe, that means we need to have words. Okay? If I said describe slope, where we got his hand was up first, so I'm gonna go with him, but then you are number 2. Okay, where do we got?
The rate of change.
The rate of change. Okay. All right. All right. I'll go along with the rate of change. Roz?
I believe my answer actually belongs to the method.
Okay.
So I'll wait.
Okay. That's a solid one. Okay. Because I already know what you're gonna say. Is it 3 words?
Yeah, I like that.
Yep. That's in the method. Okay. What else? How else could we describe slope? Rate? No, because the rate doesn't actually change.
Is it linear?
Well,
Could be.
So slope is found on what? It's on a line, right? What part of the line is it? All of it? What do you mean by angle?
I mean the direction it's facing.
So like the steepness or the pitch of the line?
Yeah.
So the angle that the line is like with the axis and stuff?
Yes.
I'd go along with that.
Yes, that's what I said.
Okay. So far we've established that the slope is on the linear function. Okay, so it's on lines, it's not on curves, it's just on lines. Okay. That it's the rate of change of the line, or it's the steepness and pitch of the line. Okay. I like that. Roz, talk to me. Give me my 3 words.
Rise over.
Rise over run is the easiest way that you probably remember what slope is. Okay? Rise over run. Now, can we expand that a little bit? Well, let's build off of rise over run. What do you got?
I guess it's the y-axis versus the x.
How about change in y over change in x?
Yeah.
Okay? Okay, in math, we call change in y, we call it delta. Delta y over delta x. So the change in y over the change in x. Okay. Anybody else? Another method to find slope? What do we got? What part of it in y equals mx plus b am I looking at?
Slope is it?
Slope is just the m part, right? Okay. So, but we're just talking slope right now, so it's just the m part. Yep. Okay. So if we have the equation of a line, we can find the slope of that line by just looking at the x coefficient. Okay. Anybody got another one?
Change of what?
Do we like plus though?
No, minus.
Minus. I like minus better. So I will put that one under rise over run. How's that sound? Okay. Oops. Row. Wrong colors.
Is it not the same as change in y over change in x?
It is, yep. And so it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Or y sub 1 minus y sub 2 over x sub 1 minus x sub 1. It's the same order. It's the same. Okay. What?
Yeah, I'm gonna stick with rise over run.
We can, but the problem is we're not always going to be given a graph. You know what I mean? And so sometimes we're going to be given 2 points. And so this one down here, this last one down there, that's going to be how we calculate it if we're given 2 points. Okay? Let's do that. Or let's talk a little bit more about slopes then. So there are 4 different possibilities, or I don't want to say outcomes, if you will, but there are 4 different types of slopes. Okay? There's positive slopes, there's negative slopes, there's zero slopes, and there's undefined slopes. Okay? So a positive slope, an example of it would be like m equals 5, or m equals 7/4. Okay? So it can be a number, it can be a fraction, it could be a decimal, it could be I really don't want to say that it could be a mixed number because I'm not a big fan of mixed numbers, so okay. So we got that. What it looks like is if we were to graph it, it would go up and to the right or down and to the left. And that is the description that typically we talk about what the line is doing as it's going to the right. So if we would always start with it's going up and to the right, or it's rising as it's going to the right. Okay? But also, because lines go in both directions, you can also say down and left. So that is an example of a positive slope, what it looks like, and its description. Negative slopes. A negative slope is going to look like a negative number, so like m equals -1, or m equals -2/3. Instead of going up and to the right, it's going to go down and to the right. Or it will fall as it's going to the right. A zero slope is literally going to be m equals 0. Okay? Now, that 0 may be, you may see it when you're doing the math as 0 over some number, okay? But 0 divided by any number is just 0. So that's why it's just 0 there. So if we think about this in terms of rise over run, okay, we're not rising at all, but we're running a lot. Okay? So when we're not rising, but we're running, that is a horizontal line. And our last kind is an undefined slope. And literally,
So it's not like a variable.
nope. Slope is a number. Okay? The variable is part of like the line, but the slope is just a number. Okay? So if I ever ask you for a slope, and it was like y equals 5x plus 7, and I asked you what's the slope of that line? The slope is just 5. It's not 5x. So here, it's not infinity, it's undefined, because it's going to be some number divided by 0. And we can't divide by 0. That's the problem. Okay? So what does it look like? So now if we're thinking rise over run, right? We're rising, but we're not running. So that's a vertical line. So those are the 4 choices that you have for lines in math. Positive slopes, negative slopes, horizontal. Let's put this to work. So the directions for these, there's 4 of these problems. There's 2 more traffic down below. We'll release them here in a minute. The directions for these 4 problems are find the slope. So that's 1. The first thing we have to do is we have to find the slope for these between these points, and then tell if it rises or falls to the right, is horizontal or is vertical. Okay, so there's 2 parts to this one. So first off, we're going to remember that if in betwixt 2 points, it's y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Okay, so we're going to use that formula every single time. Okay? So we're going to subtract the y's. 5 minus negative 2 over, subtract the x's, negative 3 minus 5. Now, does it matter which order you go in? No, as long as you personally stay consistent. Okay? 5 minus negative 2 is like 5 plus 2, and that is 7. Negative 3 minus 5 is negative 8. So I get here that the slope of,
Wait.
What's up?
So negative 3 is the second x?
Sure. But like I just said, I could have done this. I could have done negative 2 minus 5 all over 5 minus negative 3. Okay. Just flip flop my order. Negative 2 minus 5 is negative 7. 5 minus negative 3 is 8. Those 2, black and purple, are the exact same fraction. Negative 7. Doesn't matter which order you're going to, or which order you're going to. Okay?
5 minus
Is 8. It's like 5 plus. All day. Okay? So, you got a negative slope. Does it rise or fall to the right? Is it horizontal or is it vertical?
falls to the right.
Falls to the right. That would be the second part of our question. Try one more. 8 minus 8. 7 minus negative 8. 8 minus 8 is 0. 7 minus negative 8 is 15. Slope for this one?
No, it's horizontal.
It's 0. Yep. Slope is 0. Which means it's what kind of a line?
Horizontal.
A horizontal line.
So I was right. I'm right.
try those two. Make them up a little bit higher, which means now I gotta bring it back down. There you go. You do those two. I got -6 over 0. That's not possible, so that gives me an undefined slope.
Oh, yeah, because I did it wrong, so you're right.
No, it's just make it small. Divide by.
If you're dividing by, you divide by a small.
If you multiply by a fraction, how make it small?
Well, you're not. You're dividing by a fraction.
So it's right, so it's like
So
dividing
if
it
you,
to small
no,
amount.
if you.
All right. So here, let's just do it. So we got 2 minus -4 all over 3/4 minus 1/4. So that is going to be 6 on top and 1/2 on the bottom. Right? Because 3/4 minus 1/4 is 2/4. 2/4 reduces to 1/2. Okay?
Yep.
When we're dividing by fractions, that means we flip the second fraction and we multiply. So 6 times 2 over 1 becomes 12. So the slope here is positive 12. Because the slope is positive, that means that it is going to rise as it goes to the right.
Are we taking the test this week?
Formative. Friday.
Is it gonna be on this?
Yeah. And
We got homework due this week too.
This one?
Oh, that's not done with them?
Alright. So the next part of slopes is talking about parallel, perpendicular, and or neither. Okay? So if I said we've got parallel lines, okay, what does that mean to you?
They'll never intersect.
They'll never intersect.
They're the same slope.
They have the same slope. Different y-intercept slope. Okay, right. All good things. Okay. Okay. So parallel lines never intersect, and they have the same exact slope. Real world example of parallel lines? Train tracks. Roads. The lines on the roads. Roads. Where we're going, we don't need roads.
Pretty sure roads intersect.
Yeah,
The
line.
line.
The line.
Hang on the line.
I don't know.
Right?
Shut up.
I'd actually go. I'd almost go like on the next one. We could do roads too, right? Right? What about perpendicular? We're gonna go perpendicular.
Opposites.
What about perpendicular? What about 2 lines that are perpendicular? What do we know? Luca, why don't you just tell us?
90-degree angles?
They intersect at a 90-degree angle. Okay? So perpendicular lines intersect at a 90-degree angle. Okay? So that's one of these things. Remember our old
They have
valve.
opposite slopes, right?
Hold on, we'll talk about that. Okay? So if they're going to intersect at a 90-degree angle, what can you tell me about their slopes?
Well, I said they're opposite.
They're opposite. Okay? Is that it? What do you mean by inverted? It's an R word in that.
That means the
The
slopes are different.
reciprocal.
Bingo. Oops, I got it.
Boom. Oh my gosh.
I think I was right.
Okay? The slopes of parallel, or excuse me, I almost said parallel lines. The slopes of parallel lines are exactly the same. The slopes of perpendicular lines are opposite reciprocals. Now, let's break that down here for a minute. Let's talk about those two words. Opposite. What does it mean to be opposite?
Besides saying.
A negative and a positive.
One's got to be negative, one's got to be positive.
Okay.
So if you are comparing two slopes and they're the same sign, meaning they're both positive or they're both negative, they cannot be perpendicular. Okay? Because one has to be positive, one has to be negative. Okay? What can you tell me about reciprocal? What can you tell me about the word reciprocal in math? It was?
That was funny.
No.
It's like a.
What do we do with it? To find the reciprocal. What do we do with the number to find the reciprocal? You flip-flop them, yeah. You flip it over. So in order to be perpendicular, they have to be both opposite and reciprocal. Can't just be one. Gotta be both. Okay? So if this were a fraction, so like let's say that my original slope was the fraction A over B. Okay? So that's my original slope, A over B. Whatever you want it to be there. Okay? The perpendicular slope, remember that the symbol for perpendicular is an upside down capital T. Okay? The symbol for, so if they're perpendicular, what's the new perpendicular slope? Negative B over A. Gotta be both. Can't just be one. Then, if we're parallel, we're parallel. If we're not parallel, we're perpendicular. If we're not parallel or perpendicular, then it's neither. Then we just call those lines skew. Skew lines are non-parallel, non-perpendicular lines. Okay? So let's put this to work. I'm asking the question, are these two lines parallel, perpendicular, or neither? Okay? So the first thing that we have to do is we have to find the slope, because the slope is going to tell us everything about parallel, perpendicular, or neither. Okay? So the slope of the first one is going to be -1 minus -2 all over 5 minus 6. -1 minus -2 is +1. 5 minus 6 is -1. So the slope of this line is -1. Agree?
Yeah.
Okay. Go down here to line number 2. The slope of line number 2 is going to be 3 minus 8 all over -2 minus 4. 3 minus 8 is -5. -2 minus 4 is -6. So that is a slope of 5/6. Are those slopes exactly the same? No, so it's not parallel. Are those slopes opposite reciprocals? No. So if they're not the same, they're not opposite reciprocals, then the answer is the these two lines are neither parallel or perpendicular. Good times. Good. Good times. You try. In the end, you just guys are going just two different directions, so you should end up in the same spot.
Oh, yeah, it's because it should be negative 9.
Oh, so you do it wrong.
Negative 9 to 1.
So 3 minus 4, or 4 minus 3, all over negative 9 minus 0 is going to be, so 3 minus 4, that's negative 1 over negative 9, so that is, I get a slope of the first line as 1/9. Yes?
Yes.
Yes.
Yes, sir.
Okay. All right. Slope of my second one, negative 4 minus 5, all over 3 minus 2. That's going to be negative 9 over 1, which is negative 9. Yes?
Yes,
Yeah.
sir.
Are they the same?
No.
No, they are not the same. Are they opposite reciprocals?
Yes.
Yes, they are. So therefore, these lines are
They are
they
perpendicular.
are perpendicular.
Yeah. But H is square root.
All right.
Wait, I thought we didn't have class on Thursday, right?
Tuesdays, no.
Nice try though. Good try. You don't have to come tomorrow if you don't want.
Okay.
Wait.
You still mark me here though, right?
No.
Oh.
He's gonna say it anyway.
Now, this kind of problem is a big, or I should say, let me rephrase that because I kind of started and then my sentence go. This style of problem is usually given to us from the test. They really like this kind of problem. It's been on the final for the last like 5 years. Okay. So I see that this will probably be on the final this year too. Okay. So what this is asking, what this style of problem is asking is we need to find a value for k right there to make the slope between those 2 points to be negative 2. Okay, so that's what we're asking in this problem, or what this problem is asking. And so I would start with the slope formula between 2 points. And so now we know some things. Okay, what do we know?
And equals negative 2.
M is negative 2, so let's put negative 2 in for M. What else do we know?
4, 3, 5, 3.
So the top, so the numerator, is that top or is that bottom?
Top.
Top, 4 minus 3,
4 minus 5.
4 minus negative 3. Okay. Bottom then is what? K minus 3. Yes? Okay. Is there anything that I can do to make it look a little bit prettier? Well, how about first, let's do this. Yeah. Okay. Now, what are my options? Multiply by k minus 3 on both sides. Or I could put the negative 2 over 1 and cross multiply. Okay. Both of those are the same. Okay. So So let's multiply here by k minus 3. And multiply by k minus 3. Okay. So then that's going to give me negative 2 times k minus 3 equals 7. Distribute in a little negative 2 action. That's going to give me negative 2k plus 6 equals 7. Now what? Subtract 6. That's going to give me negative 2k equals 1. Now what? Divided by negative 2. Negative k equals negative 1. So what that's saying is saying that if my value of k way back up right up there, my value of k is negative 1/2. The slope between those 2 points is negative 2. Let's quick check it. Okay. 4 minus negative 3, that's going to be 7. Negative 1/2 minus 3. So negative 1/2 minus 3, that's going to be negative 3.5, right? Okay. So that's going to be 7 over negative 7/2. Flip and multiply. So that's going to be 7 times negative 2 over 7. 7 divided by 7 makes that go away, which just makes negative 2. Okay. On your pink sheet,